Hi, and welcome to my presentation on chemical reactions and energy. I'll be talking about this topic in two videos. The first one, this one, is about the differences between exothermic and endothermic reactions, reaction profiles, and activation energy. The second video is based on bonding energy data and how to use it for calculations. So, first of all, it's important to know what happens to energy in a reaction. A reaction is successful when two particles collide at high speeds and have enough energy to react. When this occurs, energy is transferred to or from its surroundings, typically in the form of heat energy, as you can see in my wonderful diagrams below. These reactions are classified as exothermic and endothermic reactions. In exothermic reactions, energy is transferred to its surroundings. This causes the solution, the container, and even the air to a small degree to get much warmer as the temperature increases. On the other hand, in endothermic reactions, the opposite occurs. Energy is transferred from the surroundings to the reaction, and as you might expect, this causes the solution, air, and container to get much cooler as the temperature decreases. These reactions can be identified in other ways than just physically touching them, however. Reaction profiles, otherwise known as energy level diagrams, are used to show whether a reaction is exothermic or endothermic. The total energy of the reactants and the total energy of the products is shown on the diagram, as is the difference between them. In an exothermic reaction profile, the energy level of the reactants is higher than that of the products due to the fact that the overall energy level decreases. It decreases because, if you remember, it transfers energy to its surroundings. This release of energy is shown on the diagram as a green arrow. In endothermic reaction profiles, once again, the opposite occurs. The energy level of the products is higher than the reactants due to its drawing in energy from the surroundings. This transfer is again shown by the green arrow. Taking this further is the addition of activation energy. Activation energy is the minimum energy the particles colliding need to successfully react. If a particle has less energy than the activation energy and it collides with another particle, nothing will happen. This required energy is shown as a hump on the reaction profiles. This hump always starts at the reactants, and as such, the value of the activation energy is equal to the peak of this hump and the starting reaction energy. The final thing for this video isn't actually on the specification, but I'm going to mention it anyway because it ties in well here. Catalysts are substances that are added to the reactions to increase the rate that the reaction occurs. They reduce the activation energy that is required for the reaction, and in doing so increases the chance that colliding particles will react. This heavily increases the rate of reaction. So yeah, anyway, that's it for this video, and I will see you in the next one.